Tom has crafted a lot of policy. Actually, Tom, can you tell him a little bit what you did with the OCG?
Sure. Yeah. So I worked for two presidents, President Clinton and President Obama. And for two different parts of the White House, the National Economic Council, which coordinates domestic and international economic policy, and the Office of Science and Technology Policy. And when the president in the State of the Union would say, "Today, I'm pleased to announce that we're going to do X," my job was to try to help come up with the X's. So examples of things that I worked on were the promotion of the internet in the 90s, the National Nanotechnology Initiative, which President Clinton announced in January 2000, which has resulted in $40 billion in funding for nanoscale science and engineering, getting first DARPA and then every agency the ability to do incentive prizes for up to $50 million. And then the BRAID initiative, where the goal is to try to do for neuroscience what the Genome Project did for genetics. So it's broadly interested in science, technology, and innovation.
And as a direct beneficiary of the America Competes Act that allowed essentially incentive prize challenges for the government to put out. So rather than having to fund people to do the research, you could actually set this ambitious challenge and then people could respond. And I'm sure you all are familiar with like what that means. But when I was at IARP as a program manager, it was because of that work that we were able to launch our first challenge, which I think actually provided tremendous ROI. That meant, obviously, that you were thinking of many different ways that the government could essentially achieve its mission without just sort of relying on sort of the standard playbook of funding and policy. So where you are now, like what were other sort of new mechanisms of funding that you did in government, and what are you most excited about now?
So broadly speaking, currently the U.S. government has a widely utilized mechanism for making financial commitments that are contingent on failure. So if you were to look at the balance sheet of the federal government, what you would see is trillions of dollars of loan guarantees. So that is the government saying, "Hey, Adam, if your business goes bankrupt, the U.S. government will assume your debt obligations." So it's an if-then statement, but the if is predicated on failure. And so what I think is interesting is increasing the capacity of the government, but also other institutions as well, to make financial commitments that are contingent on success. So NASA, when the U.S. retired the space shuttle, NASA had to give the Russians $50 million every time we wanted to send an astronaut to the space station. And no one thought that was a particularly good idea. So NASA said to SpaceX, "Build us a rocket that can go to the International Space Station, deliver and retrieve cargo, and we will buy rides on the rocket, but we'll also provide you with milestone payments for intermediate progress towards that goal." During the Trump administration, the way Operation Warp Speed worked is the government said to Moderna and Pfizer, if you develop a COVID vaccine, which is safe and effective, then we will buy 300 million doses. So there's an if-then statement, but now the if is predicated on you being successful as opposed to you failing. Yeah. So, if I were king for a day, I would create a marketplace of outcomes that has three participants, the entity that's willing to pay, like NASA was for the Falcon 9 rocket, the team that believes that they can achieve that goal, and the investors who are backing that team. So that works primarily in those instances where you can define what winning looks like. So for example, for the DARPA self-driving car competition, the finish line was literally a finish line. There was an obstacle course. You had to get to the end. The second time they ran it, a Stanford team won.
That's right.
Larry Page was at the finish line, and he promptly acquired the winning team. So that's where Waymo, Google X came from.
Yeah, I knew you just got here, but the conversation today, the ideas are just really incredible, robust. Do you have a little inside baseball though? Let's say someone here is like DB German believes like if there were an outcome that we achieve in some particular area of either security or privacy, for example, how would they go about like trying to seed an idea like that in the government to do this sort of triangulation you just discussed?
Yeah, so when I worked for President Obama, people would come visit me and they'd say, "Tom, you're never going to believe it, but it turns out the thing that I work on is really important." And I would say, "Gosh, I'd never heard that before. What is it that you want the White House to do?" And a shockingly high percentage of the time, people did not have a good answer. So the thought experiment that I always gave people is, you have a meeting with President Obama, in the Oval Office, and he says, if you give me a good idea for, whatever, AI and human flourishing, then I will call anyone that will claim it. It can be a conference call, so there can be more than one person on the line. If that person works for you, right, the head DARPA, I'd be directed would be something because I'm their boss. If it's someone outside of government, I could challenge, do something. So you not only do you have to tell me what your idea is, but in order to make your idea happen, who would I call alone and ask them to do? So that is the White House version of the Heilmar cast.
Okay.
If you could call anyone, who would you call and what would you ask them to do? So the premise of the thought experiment is that complex problems require building coalitions, and it is very difficult to build a coalition if you cannot articulate the members of the coalition and the mutually reinforcing steps that you want them to take in the form individual or organization A takes action B in the pursuit of goal C.
Check. Yeah. He mentioned the Heilmar questions. Has anybody heard of those before? Oh, wow. Okay. Yeah, if you've ever been through an ARPA, it makes you instantly sweat. My hands are sweating because George Heilmar was the director of DARPA who came up with what's called the catechism. There are 8 fairly simple, like deceptively simple questions that essentially every program you see coming out of DARPA has to answer these questions. And they basically load on the same factors of like, what are you trying to do? Why can't we do it now? What are the limitations? But then who cares?
What's new in your approach?
What's new in your approach? This is always and by the way, the answer can't be, well, I'm just smarter than everybody else, which rarely is the case. But the story you just told is people come to you with ideas. One of the terms I used, which will never be used again, was harvestigate. So how do we use the ideas that are here now, but also continue to investigate, right? What's the right way for us to find and identify like new potential public goods? How does the government do that? How should it do it? How do you do it?
Yeah, so I think one thing that is underrated is unbundling idea generation from execution. So the way we usually do research funding is that we assume that the same person who has the idea should also be the person to execute the idea. And I don't think that's necessarily the case. So I think there are some instances where you just want a lot of ideas. And so why might you want to unbundle those? Well, in part, because the person who has the idea may not be in a position to actually execute the idea. So for example, there are a huge number of opportunities at the intersection of AI and health, where the challenge is that a number of organizations are hoarding the data, right? So you may have a researcher who could articulate, this is what I would do if I could get access to the data, but I don't personally have the political juice necessary to make this happen. But if you give me an opportunity to send my idea into someone, I can tell you, what I think the opportunities are. So that's sort of one thing that I don't think that we do enough of is unbundle idea generation from execution.
Interesting. So in terms of the idea execution again, idea generation, where we sit at the ARPAs, we are used to, because there's a large budget, you're used to people coming to you,
yes,
which makes you lazy in some cases, right? In particular, a lot of complaint, as you can imagine, is like, well, the talent in AI is very thin. And that's probably because the talent they see is the stuff that's going to, the large ads. When you actually get out there and start hunting, you realize, oh, actually there's more than you think. What would you recommend for like a field strategist sort of approach? Is Renaissance Philanthropy doing that?
Yeah, so our vision is that in the same way that wealthy Italian families supported the Italian Renaissance by backing Michelangelo and Vinci, today's philanthropists are positioned to support a 21st century Renaissance that is fueled at least by basis in science, technology, and innovation. And one of the ways in which we do that is we design and launch thesis-driven funds that have, the problem that we're trying to solve and why we think philanthropy can play an important role, the team that would do a world-class job of leading that effort, and the philanthropists and foundations that are backing that. And we can and do start with any of those three. So sometimes someone comes to us and says, I really want you to launch an initiative in this area, and I'm willing to be the anchor donor. Sometimes we have the idea and we're trying to convince the rest of the world that we're right. So another DARPA alum who was our chief scientist, Joshua Elliott, believes we're underinvesting in climate emergencies. So those are areas where we're nearing an irreversible tipping point, like the impact of the West Winter ice sheet on sea level rise. And in that case, we're trying to convince the rest of the world that we're underinvesting in this area, that we should be doing more. And then sometimes someone walks in the floor with a brilliant idea that we get excited and they're quite support.
Yeah. I'm going to ask about how crazy you can get. How crazy can we get when it comes to like all right, I'll make your point. Especially in terms of like the funding mechanisms, for example. So here's my crazy idea is figure out some way, maybe springing some AI in this, figuring out some way that you can have outcome-based challenges or funding approaches that also reward the people who have already done the work and didn't even know they did it, right? People, if you show the data, for example, so a database, so it's used later on, for example, PDV, and AlphaFold, and they get tangible rewards.
As opposed to just the warm glow of knowing that they contributed to the public good?
Well, I think that's super important. Won't buy you the old Jism.
Yeah, so my understanding is that that's one of the ideas that this community has, which is retroactive funding of public goods. So
They already thought of it?
Yeah, they already thought. So I think the issue is that I was talking to someone about this, is that there's this concept in people who study social networks, not as in Facebook, but as in, relationships between people. And there's this concept of structural holds. So if you were, for example, if you were looking at a social graph of a high school, you would see jocks and nerds, but very few people who are members of both the jock clique and the nerd. Like maybe you were one of them.
We're called jerds.
And so similarly, I think there's a danger that if you have this idea that sort of rose up in the crypto blockchain Web3 ecosystem, it never makes it out of that because there's not enough people who are in a position to play this bridging role between this concept like retroactive funding of public goods with other communities that might be interested in potentially supporting it. So you need more ambassadors and people who can engage in that sort of boundary standing. So for example, the idea for advanced market commitments grew up in the global health community because they had this very specific problem, which is left to their own devices, drug companies will not work on vaccines for poor people because they have no money. And so I found out about it in the context of that market failure. And what I discovered is no one in any other field other than global health had heard of that idea. So when you find one of these ideas, you need people who are going to engage in sort of proselytizing and boundary spanning. Otherwise, it will just get stuck. And the only public goods that will be funded are the ones that are of direct importance to the Web3 blockchain crypto community, as opposed to saying, how do we get more people interested in this idea of decentralized funding of public goods?
Yeah. And again, at DARPA, we talk about a good problem, and you can tell a good problem because the people who solve it are not the people that you ever would have thought about solving it. My first program had social scientists, sure, but evolutionary biologists, applied mathematicians, physicists brought to the table, which means, you're going to get a different perspective in some sense. Is there any place where advanced market commitments doesn't make sense?
Yes. Well, it doesn't make sense if there's no market failure, right?
That's right.
So you don't need an AMC for the next version of the iPhone. You don't need an AMC for the next, NVIDIA GPU. So it has to be an area where there's something is important, but there's some reason that the private sector will underinvest. So that's one thing. The other thing is it doesn't work well if you cannot come up with a performance-based description of what success looks like.
That's fair. Yeah.
So if beauty is in the eye of the beholder, then it's not an area where it makes a lot of sense. But if you know what you want, like I want a self-driving car, or I want a rocket that can go to the International Space Station, or we have a proxy for it. So like warts and all, we use the FDA when we say we want a vaccine which is safe and effective. Then I think it works a lot better.
Yeah, interesting. I do want to touch once more on the sort of data question. And in particular, what sort of data would you, if you could wave your wand, would you collect to really space?
So if you look at the areas where we've made progress in AI and machine learning, it is often the case that we have a well-defined problem that is leveraging the ability of AI and machine learning to serve as a universal function approximator. we have a large, high quality, diverse data set, and we have a benchmark. And so that was ImageNet for image recognition, the Protein Data Bank and CASP for protein structure prediction, and Common Crawl for large language models. There are the Protein Data Bank is the exception rather than the rule, right? So we sort of lucked into that because in 1971, that community got together and said, we want to have a well-curated data set. We want to have a set of QA, QC standards for what you have to do before you can even submit it. And we're also going to get the journal editors to agree that you cannot publish your paper unless you deposit your protein structure in the PDB. So there was, why did Demis Hassabis wake up one day and say, I'm going to work on protein folding? It's because we had $20 billion worth of structural biology in one well-curated data set. We had a well-defined problem, which is if you know amino acid sequence, can you predict protein structure? And we had CASP, which was this blind competition to know whether or not you were making progress. So in lots of other areas, we don't have that. So if I were king for a day, what I would be asking the research community is the following thing. One is, what are the important problems that we want to solve, where we believe that AI and machine learning could play a significant role? Number two, is there anything that is preventing us from doing that, right? So the answer may be no. It may be, you put you ask the frontier models the question and they give you the right answer, right? But if the answer is yes, there are many instances in which what is limiting our ability to solve that is we don't have the right data set, we don't have the right benchmark, we need to invest in a platform technology that dramatically lowers the cost of generating the data.
Yeah.
We need to have the self-driving lab. We need to take numerical simulation codes that are still written in Fortran and port them over to a more modern language so that it can support auto differentiation. So in other words, people are really focused on the AI appropriately, but what is not getting enough attention is what are the complements to AI. So economists say there are things called complements. So like hot dogs and hot dog buns is always their go-to example. So, in my view, there should be a lot more attention devoted to what those complements are. And then we have to figure out who's going to pay for them, right? Is a venture-backed startup going to pay for them? Do we need philanthropic dollars or the government to support them? Because my view is a lot of people are saying, oh, what is AI going to do to us? And the question that I think is a little bit more life-affirming and interesting is, what do we want AI to do for us?
What is our vision?
Right?
Yeah, what is our vision?
What is the civilizational tech tree that we want to build? And for the problems that we think are really urgent, is there anything that is preventing us from using AI and machine learning in combination with other computational and experimental tools from solving that problem? And if there is a bottleneck, then we should figure out how we mobilize the talent and the financial resources needed to pay for it. So for example, in addition to being CEO of Renaissance Philanthropy, I'm also chair of Convergent Research, which supports focused research organizations. And this is supporting these public goods that are accelerating progress in different areas of AI, like AI for math. One of the focused research organizations is called Lean. And this allows you to figure out whether a proof is correct or not. And so if you're doing reinforcement learning with verifiable rewards, having a ground source of truth is incredibly valuable. So that's why a lot of the AI for math startups are all building on top of Lean. But again, someone has to fund that public good for all the startups to build on. In the same way that all these companies build on TCP/IP, but like none of them would have developed it and put it in the public domain.
So let me, how are we doing for time? Are we okay? Or 4 more minutes. Okay, sorry. That's what that number, I thought that was okay, so not an explosive. We're going to be okay, people. Believe me, I would let you know if we had 4 minutes to live, okay? Well, at least 3.5 minutes, and then I'd leave, and then you guys, okay. So here's something I think a little bit about in terms of data, because I totally agree with everything you said. is after I helped stand up another ARPA. I'm an ARPA-holic, if you can't tell. So I ARPA DARPA, and I helped stand up ARPA-H. And they asked me to write an article afterwards, and they said, what are you sort of most worried about with new ARPAs? And I said, it's that they will forget that their mission is intelligible failure. Like, they're meant to fail to some degree, but there's a difference between failure and like, oops, that didn't work, and intelligible failure, which is we know why it didn't work, so we are better off, right? We know something we didn't know before. When I think about intelligible failure in the world of AI, where are the null results? Where are the things that didn't work? Where are all the hiccups and the boo-boos that are just as important for science that are not being published?
I'll give you a classic example of this. If you talk to chemists and you say, why haven't you had an AlphaFold moment? Yeah, they say, our data is behind a paywall, number one. Number two, the only thing that is published in the literature and patents is successful high-yield reactions, because no one publishes on, oh, I tried mixing these two chemicals together and nothing happens. So their data is fundamentally unrepresentative. And if they were generating data for the purposes of training a machine learning model, they would do it totally differently from legacy data sets. So they would have more metadata, they would have more data on intermediate reactions. So you might say, well, why isn't this happening? One of the important things to know is academics are rewarded for novelty as opposed to utility. So they would get a publication if they said, I created this novel data set. But if 3 months went by and what they'd done is double the size of the data set, they wouldn't be able to go back to the journal editor and say, hey, here's my other publication. They do a desk reject. They'd say there's nothing new here. All you would just generate new data, right? So there are things that move the entire field forward that the people that we were counting on to solve these problems are not incentivized or paid to do. So that's why there's an Octant logo here. So one of the things that ARPA-H is doing is they are using Octant as a contract research organization for open science. So Octant is being paid to generate data sets that could potentially transform the way we do drug discovery by being able to predict in advance whether a given small molecule is likely to be toxic or have the other elements of a small molecule that are essential for it to progress successfully in a clinical trial. So we need to be, the whole premise of meta-science is that we should be applying the experimental method to how we fund, organize, incentivize, and staff research. And this ARPA-H Open AdMet Octant collaboration, I think is a really interesting example of that.
Yeah. Speaking of institutions that probably need to co-evolve a little faster, modern publication institutions. Okay, last question with a minute left to go. So again, I sort of invent these concepts out of nowhere. One I have is called LQ, learning quotient. Let me say again, learning, because I spent years in England, so I say my L's like W's. What's a learning quotient? Learning quotient. We have all these fun experiments, important experiments that are being done. Are we collectively learning from all of these things better? And if not, how can we?
Yeah, I think the hardest part is having people be explicit when something doesn't work, right? So I think the problem is that something will just go away, right? And then if you like ask around, people are like, yeah, it didn't really work. But like no one is motivated to say, yeah, we tried this and it like blew up in the launch pad. So I think that's the issue. I think there are some areas of science where we can create these, like at a technical level, these really fast feedback loops between computational and experimental approaches. But I think the hard part is the sociology of rewarding people who raise their hand and says, yes, we tried this and it was a complete disaster.
True of science, also true of government, right? That there are all these experiments that are occurring everywhere. And are we collectively smarter for that?
Yeah, I think that'll be fine. Yeah. But one thing that the government did was it created these programs where we would provide small grants for new ideas we're trying, medium-sized grants to validate promising approaches, and large grants to scale things up. So I think that is a mechanism that we should be doing more of, because I would say that is still the exception rather than the rule.
Totally. And I have to remind you as an anthropologist, we're all in this together at the end of the day, right? So hear ye, hear ye. Thanks, Tom, for your time.
Thank you.
Thank you very much.